scale ECG. B dot ist team can go down. This one can go down. Go to D12. The schedule. Okay. 19th, and then it's going to be the into the math. Yeah. That's fine now. So let me see what is there. It's not for 8 hours. So you are done? You guys are all done?
I'm done, Mom. Thank you. Yeah.
Okay, so everybody's
Yeah,
done?
please.
Okay.
Yes. Ma'am, have a small question.
Who is that?
It's in home speaking.
Yes. Yes.
It's about the hematology. We have the hematology done, and
Yeah.
we are received the review question you said with the answer. Right?
Yes. You didn't
Okay.
receive it till yet. Yes, you didn't receive it till yet because after that last week class, I have the class
Okay.
today only. So okay,
Yes.
so I'll send
Yes.
it.
Yes.
Don't worry for that. You already did the hematology completed. I'll give you the answer. Yeah, don't worry for that. Okay.
Okay. Thank you. I just
No.
keep for review.
No,
Thank you.
it's okay. It's okay. Thanks for reminder. I will do that.
Thank you so much, ma'am.
Yeah. So see, this is the ECG course information. I like to tell you total hours is 32 hours. Is lot of understanding, lot of remembrance, so that you can understand the ECG and pass the course. Theory is only 32 hours. Okay, another 8 hours in a week. We are getting the 40 hours, right, per week. 20, 20 hours, 20 hours and 20 hours, total 40 hours, sorry, total 40 hours in 2 weeks for the total ECG. But here they give 32 hours because 8 hours they are giving only for the midterm review. In between, we have 2 exams and you guys have to do some assignment and some video learning and semantics learnings. So this is for practical. Now no marks is coming here. It is going to be your LSP marks, what you are going to do. So this is, you can see, and the crow requires skills who has already passed that laboratory skills and hematology, they can come to this course, but and hematology. So basically LLSP and hematology needs to be done, passed before you take this course. So this is your prerequisites, okay? So let me go, what is the next one? This is what we are going to learn. Obviously, this is, we learned all the hand washing, these, that. So we are going to do the ECG, how to do the ECG, what is the Holter monitor, what are the different types of ECG, how to do the ECG, what are the meaning of the ECG, what the different, we already did when I learned the anatomy in the cardiovascular system and also hematology system. We learned a lot of things, but I don't know. So how much you remember or not? It's up to you. Now we are going to start whatever safety manual you already have. So I'm not going to waste that time. So let us do this one. Okay. So after I teach this unit, you guys have to do these things. So we are going to learn the video together, then test your knowledge, heart anatomy, and test your knowledge, valves of the heart. You should know by this time. Anatomy of the heart, different parts, structure, name, you can, what is called, if there is a heart figure, you will be able to label the different parts of the heart, valves of the heart, what are the different functions of the parts of the heart. You guys should know that. So this is just to review this one. We are doing this one, and then we are going to, you guys going to do this one, and then we have to go through a little bit faster so that I will try to touch to the unit 2. Let us see how many slides are there. So you have assignment 30% mark, test 1 20% marks, final exam 40%, and professionalism 10%. Professionalism including your presence, your active participations, everything. Everything. So yeah, you have to answer and participate in the class activities, not you can stay quiet. Okay, so now we are going to Okay, let me little bit automatic zoom. So these we already learned where the heart is located, what is the size of the heart, what is the shape, what is the size of the heart?
Fist size, ma'am. Your fist.
Okay, so did anyone log in Sabana? Sabana was asking for login. Did anybody help her?
Yes, ma'am. I managed to log in. I'm here.
Oh, you are already here? Okay. No, I just saw
Yes,
your
ma'am.
message. That's why.
Yeah, thank you. I was just having trouble because I had a new phone, so the authenticator wasn't working.
It's okay. So I like to make you present. So yeah. Okay.
Thank you.
And where the heart is located?
Behind the
Mediastinum,
pericardium center.
behind the lung, rib
Sternum.
cage,
Yeah.
sternum, beneath the sternum, yeah, and in the mediastinum region.
Yeah.
How heart is angled? What size is what is called? What is the top portion of the head and the bottom bottom portion of the heart is called?
The top portion is called the base and the bottom is the apex.
Okay, apex is pointing towards
The left,
Left.
like
left,
downwards.
and yeah, and apex is pointing towards the
It would be the left kidney, like it's pointing on a downward.
no. Apex, yeah, apex is in the downward, but the base in the up. So
Oh,
if it's the
above
left,
the
it's going to be the
diaphragm.
right. Okay. So heart is just touching just above the diaphragm. So in the questions comes, heart is located, is the region is called the mediastinum. Yeah. What? It is lying in front of the spinal column. Where is the spinal column? Is in their back, right? So in between the sternum, which is in the front bone, and the back is the spinal column. See, in between this, heart is located, and in between the two lungs. So from front to back is in between the sternum, is behind the sternum and front of the spinal column, and from side to side in between the two lungs, left and right lungs. But 2/3 lie to the left of the midline. What we saw here, 2/3 of the heart is lying towards the midline, though is situated in between the sternum, behind the sternum, front of the spinal column, and between the left and right lungs, but it is oriented little bit slightly angled. So mainly 2/3 is oriented towards the left side. Apex just lies above the diaphragm. So this is our diaphragm. Which is diaphragm? What is the function of the diaphragm? What is diaphragm?
Diaphragm sits in between, and I think it helps with respiratory.
Like regurgitation of the acid
No.
from the
diaphragm separates
It's the muscles of
cardiac and the abdominal
respiratory.
regions.
yes, the
Upper part
separates
between
the
Thoracic
separate
and the abdominal regions.
abdominal. Diaphragm is a membrane which separates the thoracic and abdominal cavity.
Okay.
Diaphragm is a membrane. So if you eat too heavy and then you try to walk, then you feel some pain on the chest because diaphragm, that the filled stomach is hurting in there. Sometimes you have to walk or exercise. During the beep test, you can, when you did the beep test in the school life, you can see that time you have some pain there. That's the thing. So apex lies just above the diaphragm and base lies at the level of the third rib. 1, 2, 3. We are going to show you how to count the rib. Ribs are very important for the ECG. What is called ribs? What is the name of the ribs? Medical terminology?
I'm not sure about the ribs, but is it intercostal spaces?
Intercostals in between the ribs is called the intercostal spaces.
Yes.
Then what is going to be the name of the ribs?
Costal?
Is it thoracic?
Costa, costa, yes, costa. Intercostal means in between the costa. That is called the intercostal. So medical term name is ribs is the costa. Okay. So it is located. The heart is located. The apex of the heart is located on the heart ribs or costal region. Okay. So apex is on the right side, and apex is located just above the diaphragm. And what is the rim number actually? 1, 2, 3, 4, 5, between 5 and 6. Okay, so this number of ribs is going to be very important for your ECG. You have to count the ribs, then use the fourth ribs, fifth ribs, sixth ribs, and in between that you have to place the electrodes from where you are going to do the ECG. And it said the size of the owner's closed fist. What are the different layers of the heart? I am not going to go through too much details. We already learned it 2-3 times. Pericardium is closed 2-layered sac. What is the different layers? Parietal pericardium and visceral pericardium. Parietal is tough, non-elastic fibers connected to which is the outside, parietal. Here. And peri is internal, is more soft, is thin. So this peritoneum, the parietal peritoneum gives more support to the heart to protect. What are the different heart walls? Epicardium, myocardium, and endocardium. So here is the difference. So in the layers of the heart, take the note, layers of the heart don't get mixed with the heart wall versus layers of the heart. Layers of the heart has the pericardium, and what is the pericardium? It consists of parietal pericardium and visceral pericardium. Okay. Then the heart wall. Heart wall is epicardium, myocardium, and endocardium. That is mainly heart wall. Pericardium is the sac outside the heart which protects the heart. And heart walls is the walls which is making the heart. So epicardium is the outermost layer, myocardium is the middle layer, and endocardium obviously it's lining the inner side. What is the most thickest part of the heart wall? Myocardium questions comes. Thick middle layer of the heart composed of cardiac muscle cells responsible for ability to contract. Which heart wall has the most power to ability to contract? Questions will come like that. What is the myocardium? What is the most powerful contract has the most contract power? The myocardium. So questions come in different way, but you have to remember myocardium, that is the most muscle layer composed of cardiac muscle cells. When you did the muscle tissue, you remember the cardiac only made up of cardiac muscle cells, other are skeletal muscles. But here the myocardium is made up of cardiac muscle cells and which is responsible to contract. So you can see this is the diaphragm where the apex of the heart is slugging. This is the epicardium. This is the myocardium, and inner is the endocardium. So you can see here. So this is the epicardium, and that visceral pericardium. Both are very close. This is the this is the pleural cavity in between the space where the fluid is there so that it can help the bus. So any friction. And then this is the myocardium and inner side is the endocardium. Just remember the arrangement from how it questions comes. Heart walls from outer to inner. Epicardium, myocardium, endocardium. Sometimes the questions comes in the reverse. The heart wall, they will give you the different combinations. When you say from inner to outer, is going to be the endocardium, myocardium, epicardium. So questions come in different format, make notes. What are the valves of the heart? We have learned so many times. We have two types of valves. One is atrioventricular valves and one is semilunar valves. What are the atrioventricular valves?
Tricuspid and bicuspid valves.
The mitral and the
Tricuspid.
tricuspid valves.
Okay, so Evelyn participate and Amina, right?
Yes, ma'am.
Okay,
Yes, ma'am.
okay. Except you two, I like to get answer from other people. What their function? They are connected which one? These valves are placed in between what? Except Amina and Evelyn. I need the
Atria
answer.
and ventricles.
Is that Varna?
Yes,
No.
ma'am.
Okay. Atria and ventricle. Very good. Very good. So I need this type of class participation. If you doesn't give any answer, there is going to be marks cut down from the professionalism. I need the answer. That way I understand that you understand. Otherwise, if you stay blank, I cannot understand how much you remember or what you understand. So it's the name atrioventricular valves. It's already give you the name. Atria is atria and ventricle is ventricle. So the valves which are placed in between the atrium and ventricles is called the atrioventricular valves. Can any other person tell me how what blood goes from which there are already Evelyn and Amina told that there are two atrioventricular valves. One is tricuspid, one is bicuspid. Okay, except Bharna, Evelyn, and Amina. Anyone? What is the another name of the bicuspid valve?
The mitral valve.
Mitral.
Okay, so just give me. Who give the answer?
Sharina? Fajardo.
Okay, very good. Okay, so now tell me how the blood, which part of the or the tricuspid and bicuspid valves are gateway of what type of blood movement? From where to where? Blood moves from where to where? Which place to which place? Say, for example, give me one, anyone, Louis, you give me the answer. The blood tricapsid valves allows the blood to flow from which place to which plate or which chamber to which chamber of the heart?
Mom, I can try.
Tricuspid valve is located between the atrium and ventricle. Okay, that is right, right? Right now, tell me this valve is located between which chambers of the heart? Two? Yeah, that is the chambers of the heart. It doesn't comes back. It doesn't comes back. It only allows the blood that is connected between the right atrium and right ventricle. So blood is no. That is the I am. Listen to the question. I am asking you only the tricapsid valve. I am not asking you about the bicapsid valve. Yeah.
To the
No.
left atrium.
No. Tricapsid valve. No.
Right.
Ma'am,
Listen.
it's in the upper
Okay.
atrium.
Okay. Let me deal with Luis first. Luis. Tricuspid valve is located between which chambers? Okay. So right side. Yeah. Okay, okay. So tricuspid valve is located only between the right atrium and right ventricle. So how the, okay, stop there. Now tell me, no, it's okay. Now tell me the blood flows from which chamber to which chamber through the tricuspid valve. You told me the tricuspid valve is located between the right atrium and right ventricle. Is that right? Right. Yes. So now tell me, tricapsid valve allows the blood flow from which chamber to which chamber of the heart? Yes. So give me the answer. Is only allows the blood flow from the only one direction? One direction. Yes. So is one, but it have to make sure it is flowing from right atrium to the right ventricle. You can say right ventricle to the right atrium, that's full. You can say that is also close. No, it only allows the blood flow from the right atrium to the right ventricle. Is that clear? Is that correct? Everybody correct? Okay, okay. So now stop there, one by one. Cut it. You guys are too confused. Okay, so
Okay.
okay, yeah. So now Huda, tell me, are you there? Okay, so now bicuspid valve. You know where it is located?
Sorry, pardon?
Bicuspid valve, where it is located?
On the left?
Left of what?
Well, I was gonna say left chamber.
Left chamber, what chamber? There are so many: kidney chamber, abdominal chamber, heart chamber, pleural chamber, cardiac chamber. Which chamber?
Okay, left ventricle?
It is bicuspid valve is located in between which chambers of the heart? I am telling you in the name heart. Which chambers? Why it is taking so long time to answer?
Sorry, I'm gonna have to refresh.
What I told you guys to refresh it during this. You saw the timeline, your midterm is coming. I'm not scaring you. These things, hematology, this anatomy, how many times we revise this one? How many times? Joanna, you have the answer?
Yes, ma'am. It goes from the left atrium and then goes to the bicuspid with that valve and then goes to the left ventricle.
Okay, very good. Now, Maris, tell me, what type of blood is flowing from right atrium to the right ventricle through tricuspid valve? Sorry, tricuspid. What type of blood?
What can you repeat the question, ma'am, please?
What type of blood is flowing? What type?
Flowing from the right atrium to
the right ventricle.
Right atrium to right ventricle. Is it blood? Eight no. Right atrium.
Okay.
Hold on, ma'am. I was thinking.
Okay, so Jinaida. Okay, Maris. Okay, I have to go in. Yes.
You can come back me.
Yeah, you can go. Jinaida, can you answer that question?
Mom, it's deoxygenated blood.
Very good. Deoxygenated blood is flowing from the right atrium to the right ventricle through the tricuspid valve. Chris, this deoxygenated blood is coming from where to where? In the right atrium, it is coming from where?
Through the pulmonary veins?
No.
No, from your
Okay, when I
body.
asking one question, so Chris, your answer is from the pulmonary vein. Okay, so Yusra, what is your answer?
Yes, the deoxygenated blood is coming from the inferior and superior vena cava.
Excellent, excellent. So you have to remember everything. That's why if you remember the whole chart, you can answer it. Okay, and this blood next, Inghong, can you answer that? Okay, so that this deoxygenated blood from the right ventricle is going where? I am talking like a school kids. Yeah, it's going where? Where it has to go?
The oxygen blood from
Right ventricle is going where for oxygenation? Where this blood has to go? Deoxygenated blood has to go where to get the oxygen?
goes to lung.
Lung. How it goes? Through which vein or artery is going?
Sorry, could you repeat, please? Sorry, ma'am.
From right ventricle, deoxygenate blood is going to the lung through which part, which pathway or which vessel? What is the name of the vessel? Blood vessel, which is taking the blood from the right ventricle to the lung.
What vessel? Sorry, I was thinking.
Okay, Asnet?
I said that the deoxygenated blood flows from the inferior and the superior vena cava and entered into the right atrium through the tricle.
Oh, you don't have to read the whole thing, Asnet. I want a very specific answer.
It goes into the right ventricle through the pulmonary valves.
Which vessel?
It is the.
It has to go to the lungs. Through which blood vessel is going?
Pulmonary artery into the lung.
Pulmonary artery. That's the question. Pulmonary artery. Blood from the right ventricle is going to the lungs through the pulmonary artery. That's the only artery. Entire blood vascular system carry the deoxygenated blood. All arteries carries oxygenated blood. That is from lungs, which is coming from the aorta. Only artery which carries the deoxygenated blood and which going through the right ventricle to the lung. You have to read all entire pathway. What is the function of the pulmonary vein? What is the semilunar valve? What is the function of the semilunar? How many semilunar valves are there?
It's two. Similar, two.
Is Maris answering?
Yes, ma'am.
Okay, so two. Where are they located?
It's in the right ventricle and the left ventricle. The
Right
pulmonary valve is in the right ventricle and a pulmonary artery.
Yeah.
And then the aortic valve, it's in the left ventricle and trunk of aorta.
Okay, good, good. How many flaps is there between tricapsid and bicapsid valve?
We have
Can you
three
repeat that?
cups. Three cups between right atrium and right ventricle.
Yeah, that is called the tricapsid. Okay.
put this in my school?
Okay. So now it's down. We have two types of valves, atrioventricular valves and semilunar valves. You have to remember all the valves, all the septums. How many septums are there? We already told atrioventral valves located between atria and ventricles allow blood flow from atria to the ventricles. From the right tricapsid valve, it has three cups located between the right atrium and right ventricle. Mitral or bicapsid valve, this is two cups located between left atrium and left ventricle. So tricapsid valve deals with the deoxygenated blood from right atrium to the right ventricle, whereas the mitral or bicuspid valve operates the flow of the oxygenated blood which coming from the lungs through the pulmonary vein into the left atrium. From left atrium, that oxygenated blood through the control of the bicuspid valve is going to the left ventricle. And from the left ventricle, then we have the similar aortic valve which is going to the aorta which is coming next. Is that clear to everyone? I know I'm going to tell and you are going to forget again. So semilunar valves. What the all valves has the characteristics that Louis was telling. It prevents the backflow so that the never blood got mixed. When there is a problem in the valves or in the birth defect in the valves, or the valves cannot function properly, valves become weak, then there is a problem in the mixing of the blood between oxygenated and deoxygenated that may cause some heart related issue or pulmonary issue. So as we told the atrioventricular valves, so we have discussed the semilunar valves. We have two semilunar valves. One is pulmonary valve and one is aortic valve. It's easy to remember. Pulmonary valve is going from the right ventricle to the pulmonary artery. The artery which only carries the deoxygenated blood, and this pulmonary artery take the blood to the lungs from the right ventricle, and then the blood got oxygenated. There is an exchange between carbon dioxide and other gases through oxygen in the lungs, and then the oxygenated blood, which is called the pure blood or oxygenated blood, it comes to the left atrium through pulmonary
Veins.
Okay, good.
Vein.
Am I right? Or is pulmonary artery?
No, pulmonary vein.
Pulmonary vein. So then it's come from the pulmonary vein to the left atrium. Now from left atrium, the blood goes to the left ventricle. And that time, who controls the flow? Who allows, regulate that is the
mitral valve.
mitral valve. And then when the ventricle is full, left ventricle is filled with the oxygenated blood, now it has to supply the whole body. So then the ventricle squeeze and which valves open?
Aortic valve.
Aortic valve. Aortic valve opens and then the blood goes to the aorta. That is the main hose pipe of the blood vascular system, except the coronary arteries. Then from there is going to the all parts of the body, upper, lower, different types of veins, arteries go. And then these arteries ultimately go do the service in all the body parts, ultimately become the arterioles. These arterioles become capillaries. This capillary exchange They are all the nutrients and gas and everything. Then these capillaries ultimately become the venules. Then the vein forms. Ultimately, veins, all veins either from the lower part of the body, all veins accumulated or gathered in a big one is called the inferior vena cava, or from the upper side of the body, all veins ultimately from the different branches, it accumulated or gathered in a big one is called the superior vena cava. Both the inferior and superior vena cava contains the deoxygenated blood. It dumps this blood to the right atrium. So now you guys know this is the tricuspid valve. It has 3 tendons, right atrium. This is the superior vena cava, inferior vena cava. Blood is coming to the right atrium. Then this is the tricuspid valve. Blood is going from here to the right ventricle. From the right ventricle, this is the pulmonary valve. So pulmonary valve is taking the blood from the right ventricle, the deoxygenate one, to the pulmonary, through the pulmonary artery is going to the lungs. Here is the lungs, here is the lungs. So they are going to the lungs. Then from lungs, ultimately, the blood is coming to the right, from back, it's coming to the left ventricle. And from left ventricle, bicuspid valve allows the blood to the left ventricle. And then from left ventricle, you can see it's behind. The artery is going from the behind, from the pulmonary vein. That is going this right, when squeeze, it is going to the aorta through the aortic semilunar valve. Why is it called the semilunar valve? Because it's like the half moon shaped. That's why it's called the semilunar valve. So heart valve function. What are the main functions of the valve? Obviously, opening and closing is the function of the heart valves. So when the note this one, ventricular systole, systole, what that means? Systole, contraction of the ventricles. What happened when it contracts? The ventricle, atrioventricular valves close and semilunar valves open. So when these ventricles squeeze or contract, these valves close. Because why? From the blood, this bicapsid, tricapsid and bicapsid valve has to be closed. Because why? Because from the ventricles, blood goes only through the either pulmonary artery or pulmonary vein. So when both the ventricles squeeze, from the right ventricle through the pulmonary valve, blood go to the lung. At the same time, this also simultaneously squeeze at the same time, the oxygenated blood is going to the aortic semilunar valve. So these two valves, when there is a ventricular contraction, is called the systole. Ventricular, another name of ventricular contraction is systole. When there is a ventricular contraction or systole, these tricapsid and bicapsid valves close so that blood cannot go back to the atrium, because this blood has to go to the either lungs or to the aorta from the respective chambers through the respective valves, either pulmonary semilunar valves or articular. So these valves open that time. So whenever this contracts, these two valves close and these two valves open. And same thing happen when is the ventricular diastole. Diastole means when the ventricle relax. That time this ventricles, when it's relaxing, is empty now because it squeezes all the blood. When the ventricle relax, what happened? Due to the pressure fall, these two valves close and these two valves open. So that you can see these valves opening at this side and these upside and these valves opening at downside. So when the ventricle relax, the relaxation of the ventricle is called the diastole. Immediately these two valves open and blood starts to come and fill in the chamber to get ready for the next phase. So ventricular diastole, relaxation of ventricles, atrioventricular valves are open and semilunar valves are closed. These questions is going to come. What is the name of the ventricular diastole? Is the relaxation of ventricle, or contraction of ventricle is also called ventricular systole or systole. What happens during the ventricular systole? Atrioventricular valves close, semilunar valves open. The opposite in case of ventricular diastole. Coronary artery. This is very important. Two main, because heart is supplying the blood to everywhere, but heart needs own supply of blood and get rid of the deoxygenated blood from its own. So mainly the two coronary arteries are there. It's called the left coronary artery and right coronary artery, because the heart has both sides, right and left. You doesn't have to know the remember of all the names. That is really hard. So I am not going to tell you to tell everything, but you have to know that what are the different heart is supplied. This is the question comes, heart is supplied by what type of arteries? They will give different names of the arteries, obviously coronary arteries. And there are two main coronary arteries, left coronary artery and right coronary artery. Or circulation. What is circulation means? Movement through a course that leads back to initial point. So that means starting from the heart, going through the everywhere whole body, through the blood vascular system, and then is coming back to the heart. That is called the circulation. Movement through a course that leads back to initial point, the heart. So blood exits the heart through the arteries, exchange waste for oxygen in capillaries, and then back to heart it through the veins. So blood through the hearts, we have learned this one with different, with the diagrams, videos and everything. I have already described you several times. I think you guys understand blood flow through the heart. So first component, unoxygenated or deoxygenated blood flows from inferior and superior vena cava. It enters in the right atrium through the tricuspid valve into the right ventricle, through the pulmonary valve, then is going to the then until the pulmonary artery, then pulmonary artery is goes to the lung, then from the lung it comes to the pulmonary veins, from the pulmonary veins is come to the left atrium, from left atrium through the mitral valve, left ventricles, then to the aortic valve, to the rest of the body. What is the cardiac cycle? I have told you what is the difference between cardiac output, stroke volume. Who remembered what is the stroke volume? Can you raise that? Can you raise? Is that Amina?
Yes, ma'am.
Okay. Tell me what is the stroke volume?
The volume of blood that is pumped from the ventricle per beat.
I can't hear you properly. Some disturbance. Can you just repeat that? Is some disturbance in the audio?
Oh, sorry. The volume of blood that is pumped out from from a ventricle per beat.
Very good. Beat. Very good. And what is the cardiac output?
The cardiac output, I can remember it by the formula that is the stroke volume and the rate, heart rate, multiplication of the
So
cardiac
basically,
volume and
basically per
rate.
minute. Per minute. Heart rate. How many times is
Yes,
per minute? Per minute. Cardiac output is how much blood is pumped out from the ventricle per minute.
Yes, per
that
minute.
is the cardiac output. A stroke volume is per stroke or per beat.
Per
That
beat.
is the difference.
Yes, ma'am.
Thank you. Thank you.
Stroke volume times heart rate.
Yeah, that is the thing, per minute, right? So per minute, how many times the heart is beating? So you have to stroke volume. And I think it's something we told you, right? Some 5,000 or some liters or something like that. I don't remember the figure. Per minute, how much liters of blood that will not come in the question, but it's amazing how many liters per cardiac output it flows in the body?
It's 5,600 cc.
Yeah, so I almost clear. I told 5,000 something. Yeah, liter. Yeah. So can you imagine? Almost 6 liter blood per minute is going through our heart. So heart functions as a unit. Both atria contract, then ventricles filled with blood to their limits. Then blood is ejected into the pulmonary and systemic circulation. What is the pulmonary? When is going through the right ventricle to the lungs is called the pulmonary, and when is coming from the left from the lungs to the left atrium is called the systemic, and from the left ventricle going to the circulation is called the systemic circulation. Represent actual time sequence between ventricular contraction and ventricular relaxation. That is at a rhythm. Is how many seconds is going to do. That is going to be captured by the ECG. Cardiac cycle, it has two phases. Ventricular systole, one cardiac cycle is one systole and one diastole. That is going to complete the ventricular systole. That's kind of stroke volume. That is giving you the stroke volume. Ventricular systole, simultaneous contraction of ventricles, mitral and tricapsid valve closed, pulmonic and aortic valves open. That is the ventricular systole, right? We have already discussed that. And what is that ventricular diastole? It's relaxation of ventricles, both ventricles. That time, mitral and tricapsid valve is going to open, and pulmonary and aortic valves is going to be closed because the ventricles now needs to be filled up from the atrium. Stroke volume. Just I told you volume of blood pumped out one ventricle of the heart in a single beat or contraction. Approximately 70 cc blood per beat in one ventricle. If it is two ventricles, it's going to be double. So per ventricle, approximately 70 cc or ml blood is going out through the ventricle. So normal heart rate is generally 62. These questions, normal, what is the normal heart rate? These questions is come. What is the reference range? 60 to 100 beats per minute. Right note, this question is comes. Normal heart rate. What is the tachycardia? They will give you the option, different types of 60 to 100, 100 to 200, or 50, 42. You have to know tachycardia. When is tachycardia? When is over 100 beats per minute, tachycardia, and when it is under 60 beats per minute, this is the bradycardia. Brady means low, tachy means fast. Bradycardia and tachycardia. So cardiac output, stroke volume into heart rate. So if it's the stroke volume is 70 cc and your heart rate is 60, so it's going to be 70 times 60. So 4,200 something. If the heart rate is 40 and it is releasing 70 cc stroke volume, is going to be 5,600. So they generally 80 beats per minute is a very ideal, but it varies from 60 to 100. So it's 5.6 liter per minute. So they can give you the formula. They can give you if the stroke volume is for 100 and heart rate is 60, what is going to be your cardiac output? Or they can give you heart rate is this, cardiac output is this, what is your stroke volume? So you have to use this formula to calculate that. If they give you the cardiac output 5.6 liters, give you the heart rate 80, so you have to divide the cardiac output divided by heart rate to get the stroke volume, because cardiac output is per minute, right? And heart rate is beats per minute. 80 means each minute is beating 80 times. Cardiac output preload pressures in ventricles at the end of the diastole after low. This you doesn't need. The cardiac output and stroke volume is fine. What is called the peripheral vascular resistance? Amount of opposition to blood flow offered by the arterioles, the resistance by the arterioles at the end of the artery, where the artery is ending. That is called the peripheral resistance. What is the blood pressure? Blood pressure is the cardiac output times peripheral vascular resistance. That is, we are measuring when the blood is going through the arteries, is giving some pressure, pulse. And that pulse we are measuring as a blood pressure, which is cardiac output times the peripheral vascular resistance. This is the blood pressure formula. Cardiac conduction system, anybody knows? Anybody remember? What is the cardiac conduction system? How it flows? Anyone can describe me? Tell me. What are the different nodes it has? Hmm? No one? No one can answer?
What's the
Okay,
question?
What's the question, ma'am?
cardiac conduction system, how it flows.
SA node?
Go
And what do
on.
you mean?
I mean the conduction system.
Means the complete blood flow from the body going to the heart and coming out from the heart, ma'am, going back to the body.
Electrical conduction system. Blood flow is the how is blood is flowing. How is related to the electrical conduction system? That is the ECG. But what is the electrical conduction system? How it flows? To make the atrium and ventricles contraction or relaxation? What is the conduction system? How the electrical impulse are distributed or firing and passing? No one remembers anything. My God.
Travel down through.
So
What
that's
is the
yes, ma'am. That's the relaxation and
from the node
contraction of the muscle.
depolarize, it goes to electrical activity. Then it depolarized the spread from slowly across.
Can you repeat it? I can hear it properly.
Sorry, ma'am, my background is so noisy. My husband and son are getting ready to go out.
Who is that?
It's Verna.
Where you are going now?
They're going out for a nature walk, ma'am.
Oh, okay.
Yeah.
Okay, tell me what you are trying to say.
Ma'am, for the cardiac conduction system, it's like from the node it depolarized to electrical.
Which node? Yes, from which node to which node? How it function?
It's to AV node and SA node and AV node.
Yes, SA node.
What is the name of the SA node?
Sinoatrial.
Sinoatrial node.
It is located where?
In the upper posterior and right atrial.
Inside the atrium or outside the atrium?
Outside.
Outside the atrium. What it
Yes.
does?
It's
The sinoatrial node is like the pacemaker.
What it does? What is function? It fires the
Override.
first signal. It fires the first signal, electrical signal. It generates the first electrical signal that is called the pacemaker. So it fires the first signal so that then atria start contraction. And when it generates the electrical impulse, all the impulse can travel from sinoatrial node to the first two atrium. When and as a result of this electrical conduction, then the atrium contracts. It's not automatically in contracts by his mind, by their minds. When they get that electrical shock or stimulus, these the both atrium contracts. When these both atrium contracts, so that time these capsid valves open and started filling that ventricle. When the ventricle fills, then this electrical signal charge or fires to the AV node, which is in between the atrium and the ventricle. When it stimulates the AV node, this AV node sends its signal through the Purkinje fibers, bundle of his branches, and then through the Purkinje fibers, which finally contracts the ventricle. And this contraction cause the closing of the two cuspid valves and opening of the semilunar valves. That is a very simple way to remember the heart conduction system. Only couple of things, but you have to remember. SA node, AV node, bundle of his, bundle bunches, Purkinje fibers. These only couple of things are responsible for the whole heart function. SA node located in the upper posterior portion of the right atrial wall of the heart. It's a little bit posterior, but wall of the heart outside. It's a primary pacemaker of heart. These questions come, what is the firing rate of the SA node? 60 to 100 beats per minute. What it causes? It causes the depolarization and myocardial contraction occurs after impulse leaves the SA node. When that electrical stimulation, it called the depolarization of the atria and generates the, I'm coming to the ECG immediately, is coming to the, so as a result, the atria contracts. Internodal pathways, this is called the internodal pathways, are pathways which distributed impulse through the atria. So what are those? So from here, these are called the internodal pathways. So it's generate the signals. These signals is transmitted to the internodal pathways to the both atrium and also is going to stimulate the AV node. Those are called the internodal pathway. It transmits impulse from SNA to AV node and pathways distribute impulse throughout the atria. What I told, these electrical signals or the pulse, what is generated by the natural pacemaker of the heart, that is the SA node, it transmits the signal. That signal is passing to the two atrium and from the SNA to the AV node through the internodal pathways. It's going from one node to and next is the atrioventricular node, AV node. Why is AV node? Is in between the atrium, just right above the atrium, but it controls the contraction or relaxation through the atrium from the receipt from the atrium going to the ventricle. That's called the atrioventricular node or AV node. It's located on the floor of the right atrium above the tricuspid valve. So you can see the placement here. This is the tricuspid valve. Here it started here. It's located here, just above the tricuspid valve. Electrical activity delays 0.5 seconds. These questions comes why there is a delay in the sending of impulse from SA node to AV node. Why the SA node immediately send the signals to AV node? Because that time ventricles needs to fill, because if the signal goes to the AV node immediately, what is going to happen? Ventricles started to contract, and if it contracts, the ventricles cannot be filled. So there is a delay of 0.05 seconds, and by that time, whole blood filled from the atrium to the ventricles. Is that clear or not?
Yes.
Yes, ma'am, it's clear. Thank you.
So this is the only pathway from atrium electrical impulses to the ventricles. That's all from the atrium. Then whatever the next is carried out in the ventricles. So AV junction, where AV node joins the bundle of His, that is called the AV junction. So going back here, so this is the AV node. This is called bundle of His. So this is the AV node is connected with the bundle hub. This is called the AV junction. That is not important to remember, but it is written here. That's why I told you. Okay. So when SA node fails or slow below normal, AV junctional tissues initial electrical activity is called the secondary. Oh, so sometimes at the beginning, heart always body always has its own compensating mechanism, right? If somewhere at the beginning the SA node is getting slower down, cannot function properly. So what happened? Even the SA node slow, sending some slow signals or fails to signal. So AV junctional tissue, what are the tissue around the AV junction? They works as they generate some electrical activity, even the maybe slow, low. This is called the secondary pacemaker. So sometimes when the SA node fails, what is the secondary pacemaker? When the SA nodes for any reasons fails or very slow down to generate the electrical impulse, so then the tissues which is surrounding the AV node takes the responsibility to initiate the electrical activity so the heart can function. And by that time you get time to go to the hospital, to emergency, and take care of that, so that you can see what is happening. If there is a pacemaker problem or is a SA node problem, then you can do some electrical stimulation temporary, then you can do the replacement with the SA node artificial pacemaker. So that is, the body has its own defense system, compensating system. So instead of stopping the heart totally, the AV junctional tissues come forward and take some responsibility to generate the electrical activity so the heart can function. Not exactly the normal way, but heart can function. That is called the secondary pacemaker. Bundle of His, this is the conduction pathway that leads out AV node, lies at the top of the intraventricular septum, is called the common bundle, and their firing ability is 42. This is the questions. What is the firing ability of the SA node? 60 to 100 beats per minute, but in the ventricle, the AV node firing rate is 40 to 60 beats per minute. That is the intrinsic firing rate of the ventricle is 40 to 60 beats per minute. Okay. So this is the bundle of His, like the internodal pathway is the transmit the signals between the atrium from the SA node. At the same time, AV node transmit signals to the ventricle to the bundle of His, then bundle branches, and which is then divided in the Purkinje fibers. So this is the bundle of His. Then this is called the bundle branches, left branch, right branch, and then it's going to be divided as a Purkinje fibers and go throughout the whole ventricle. And these Purkinje fibers are mainly responsible for the generation, the contraction of the heart, of the ventricles, not heart, for the ventricle. These questions comes. AV node SA node, Purkinje fibers, other blah, blah, blah. Who is the main function for the ventricular contraction? Purkinje fibers. So I already told you have the bundle of His, then bundle of His is divided into two main bundle branches, right bundle branch and left bundle branch, and they conduct electrical activity bundle of His to the Purkinje network. And Purkinje network are the fibers that receive conductive signals from the AV nodes. It carries impulses directly to the ventricular muscles, simultaneously activating the left and right ventricle by directly stimulating the ventricular myocardium or the myocardial cells. How it stimulates? It stimulates the cells. What are the cells composed of ventricle? Is the mainly the myocardium, myocardial cells. What we are at the beginning we are learning. So ventricular, the myocardium area of the heart wall, which is composed of myocardial cardiac cells, cardiac myocytes or cardiac muscle cells. They got stimulated through these Purkinje fibers. And here the intensing firing rate is more low, 20 to 40 beats per minute. These things you have to remember. This comes Purkinje fibers, firing rate, bundle of His firing rate or AV firing rate and SA firing rate. So as it goes down, the firing rates become less. So this one is 40 to 60, SA node is 60 to 100, and Purkinje fibers is 20 to 40 beats per minute. Remember this diagram. This diagram is very important. This is only the induction system. This is the heart, and they are giving only the induction system. This induction system, remember, this may come in questions to label. Easy. Obviously, this is the heart is placed little bit angled. This is the apex of the heart. This is the base of the heart. On this side, you have the right atrium. So this is the SA node. This SA node is sending the signal to the internodal pathway and ultimately to the AV node. See, this AV node is then connecting with the bundle of His or His bundle. His bundle, when it started near the ventricle, it has been divided into two branches. It's called the right ventral branch and left ventral. So these left and right bundle then goes throughout, spread throughout the ventricles as a fibers. It's called the Purkinje fibers. This is the left posterior. From here, lot of branches comes out. So it's called the left posterior bundle branch. This is called, so that's why it's called the sometimes branch, bundle of His, bundle branches. These are also called it's called the bundle branches, and these bundle branches has right and left, and from there lot of branches, electrical stimulus for the stimulus branches comes, and also from these branches go throughout the ventricles, surround the ventricles as a Purkinje fibers, and these Purkinje fibers stimulates the myocardial cells in the myocardium area to cause the ventricular contraction. Let's see the video. You guys saw the video now.
A network of specialized muscle cells is found in the heart's walls. These muscle cells send signals to the rest of the heart muscle, causing a contraction. This group of muscle cells is called the cardiac conduction system. The main parts of the system are the SA node, AV node, bundle of HIS, bundle branches, and Purkinje fibers. Let's follow a signal through the contraction process. The SA node starts the sequence by causing the atrial muscles to contract. That's why doctors sometimes call it the anatomical pacemaker. Next, the signal travels to the AV node, through the bundle of HIS, down the bundle branches, and through the Purkinje fibers, causing the ventricles to contract. This signal creates an electrical current that can be seen on a graph called an electrocardiogram, or EKG. Doctors use an EKG to see how well the cardiac conduction system works. Any changes on the EKG can mean serious problems.
Oh, where are we are now? Okay. Now on the next slide, you remember the SA node, firing node. Just is a review of the electrical conduction system of the heart. SA node firing rate is 60 to 100 BPM. It transfers impulse from the SA node throughout the atria and to the AV junction. AV junction, it slows the impulse. The intrinsic firing rate is 40 to 60 beats per minute. And then from AV junction, it goes to the bundle branches, two main branches, left and right. This transmit impulse to the ventricles, and this spreads impulse throughout the ventricles. Intrinsic firing rate is 20 to 40 beats per minute. That is the Purkinje fibers. So, what is the role of semilunar valves in the heart? Santiago. Santiago?
Yes, miss. Yes,
What
miss.
is the answer? What is the role of semilunar valves in the heart?
To prevent blood from flowing back into the chamber that it just got pushed out from.
Okay.
There we go, backflow. Yeah, that's the word.
Okay. You have okay. Describe how chamber pressure is governed by the opening and closing of the heart valves.
Who's, who's entering?
Who is answering? Raise your
Who's
hand.
gonna answer?
Huh? You want to answer? Answer.
Yes. What is the question again? Describe how chamber pressure. So
Governed by the opening and closing of the heart.
yes, it's something to do with the systole and the systole and diastole.
Yes,
It's
yes.
the systole is the contraction of ventricle. It's when the atrioventricular is closed, and then the semilunar is open, and the diastole is also the opposite. The atrioventricular is open, and then the semilunar is closed.
It's called the ventricular diastole. Good.
Yeah, diastole.
Good. Very good. Describe the conduction pathway for the bundle of His. From bundle of His, he started from where to where?
The bundle of His conduction pathway lead from the outer AV node.
Then it's going to where?
Then it will go to, I guess, to the heart.
Hmm?
To the heart.
We started from the AV node, then it's going where? Chris?
It goes, okay.
Or Asanath, you can answer, you can.
I to remember that. It goes from the AV node. I think it goes back to the heart. Goes through the lungs and then around.
No, this is the conduction system. It cannot go back to the other
Remember this
places.
one.
Yeah. So who want to answer? Sabana, you can answer. Sabana, are you there? Sabana, are you there?
Sorry.
Yes, ma'am, I'm here.
Okay, can you answer? I just described so many times. So many times. Christiana. Christiana, where are you?
Yes, miss, I'm here.
What is the answer? What is the how the bundle of heat starts to communicate the electrical signals?
Sorry, how does the...
I am showing you I already showed you the question. Describe the conduction pathway for the bundle of heat.
Oh, I'm sorry. I don't know the answer.
I just described. Did you watching the my slides?
Yes, miss, I'm driving at the moment. I'm almost home.
But you missed all my lectures, basically. All my lectures, detailed lectures you missed.
No, miss, I'm listening.
But then you can tell me, right? Because I just described this one. I just crossed this part. How the bundle of heat, what is the AV node, how is sending the signals to where, to where, to where. Fazado, can you answer?
For the AV nodes, for the bundle of his.
Yes.
For the bundle of his, it was directed from the AV nodes, from the SA nodes.
What?
No, from the SA nodes send the signal for the the pacemaker, and then to the AV nodes, then to the bundle of his, then to the Purkinje.
Answer to the specific area. Conduction pathway only for the bundle of his. You are telling
It's
me
from
the
the
whole.
AV.
Yeah.
AV nodes.
Yeah. AV node too.
To the bundle of
Till
from
test.
the
Bundle
bundle
of
of his.
his. Then is where is going conduction pathway. Then bundle of his is going where?
Purkinje.
It doesn't go directly to the Purkinje fibers. There is something in between.
All this the two. Forgot the name.
Electrical activity.
Yeah. It was in the video.
Where it goes? From AV nodes, the signal goes to bundle of his. From bundle of his, it goes to where? What is the
Left
next
and right
path?
bundle.
Left and right
It leads
bundle.
out of
Conduct
the AV
electrical.
nodes.
AV node.
From the branches, bundle branches.
It leads out of the AV node.
Yeah.
It goes to the right bundle branch and then the left one, and then it conduct the electrical activities to the bundle of is to the what do they call it? Continuum network.
Well, that's easy for this one. So I don't know what is the next one. Okay, now you guys, I can show you the video and then you guys can do this one. External valves of the earth.
Yeah, sure. Your heart, that throbbing, beating muscle, is probably the most iconic organ in your body. No other organ gets its own holiday or as much radio play, and you're unlikely to get a love note decorated with a kidney or a spleen or even a brain, which is really what rules the emotions. Don't get me wrong, the heart does some great things. Namely, it powers the entire circulatory system, transporting nutrients, oxygen, waste, heat, hormones, and immune cells throughout the body over and over. But in the end, the heart does not make you love, it doesn't break apart if you get dumped by your boo, and it's not a lonely hunter. The truth is, the heart is really just a pump, a big, wet, muscly brute of a pump. And it doesn't care about poetry or chocolate or why you're crying. The heart has only one concern: maintaining pressure. If you've ever squeezed the trigger on a squirt gun or opened a can of shaken soda, you've seen how fluids flow from areas of high pressure, like inside the gun or the can, to areas of low pressure, like outside. The heart's entire purpose is to maintain that same kind of pressure gradient by generating high hydrostatic pressure to pump blood out of the heart while also creating low pressure to bring it back in. That gradient of force is what we mean when we talk about blood pressure. It's basically a measure of the amount of strain your arteries feel as your heart moves your blood around. More than 5 liters of it at about 60 beats per minute. That's about 100,000 beats a day, 35 million a year, 2 to 3 billion heartbeats in a lifetime. The basic physiology of which you can easily feel just by taking your own pulse. I don't have a watch. Now that might not inspire so much poetry, but it turns out it's still a pretty good story. Let us begin with a little anatomy. Unless you happen to be of the Grinch persuasion, the average adult human heart is about the size of 2 fists clasped together. One of the few bits of trivia you often hear about human anatomy that is actually true. The heart is hollow, vaguely cone-shaped, and weighs only about 250 to 350 grams, a pretty modest size for your body's greatest workhorse. And although Americans tend to put their right hand over their left breast while pledging allegiance, the heart is actually situated pretty much in the center of your chest, snuggled in the mediastinum cavity between your lungs. It sits at an angle, though, with one end pointing inferiorly toward the left hip and the other toward the right shoulder, so most of its mass rests just a little bit left of the mid-sternal line. The heart is nestled in a double-walled sac called the pericardium. The tough outer layer, or fibrous pericardium, is made of dense connective tissue and helps protect the heart while anchoring it to some of the surrounding structures, so it doesn't bounce all over the place while it's beating. Meanwhile, the inner serous pericardium consists of an inner visceral layer, or epicardium, which is actually part of the heart wall, and an outer parietal layer. These two layers are separated by a thick film of fluid that acts like a natural lubricant, providing a slippery environment for the heart to move around in so it doesn't create friction as it beats. The wall of the heart itself is made of yet more layers, 3 of them. That epicardium on the outside, the myocardium in the middle, which is mainly composed of cardiac muscle tissue that does all the work of contracting, and the innermost endocardium, a thin white layer of squamous epithelial tissue. Deeper inside, the heart has a whole lot of moving pieces that I'm not going to pick apart here, because the really big thing to understand is how the general system of chambers and valves and veins and arteries all work together to circulate blood around your body. Of course, fluid likes to move from areas of high pressure to areas of low pressure, and the heart creates those pressures. Form, once again, following function. Your heart is divided laterally into 2 sides by a thin inner partition called the septum. This division creates 4 chambers, 2 superior atria, which are the low pressure areas, and 2 inferior ventricles that produce the high pressures. Each chamber has a corresponding valve, which acts like a bouncer at a club at closing time, like he'll let you out, but not back in. When a valve opens, blood flows in one direction into the next chamber, and when it closes, that's it. No blood can just flow back into the chamber it just left. So if you put your ear against someone's chest, and yeah, ask for permission first, you'll hear that lub-dub. Lub-dub. What you're really hearing are the person's heart valves opening and closing. It's a relatively simple but quite elegant setup, really. Functionally, those atria are the receiving chambers for the blood coming back to the heart after circulating through the body. The ventricles, meanwhile, are the discharging chambers that push the blood back out of the heart. As a result, the atria are pretty thin-walled because the blood flows back into the heart under low pressure, and all those atria have to do is push it down into the relaxed ventricles, which doesn't take a whole lot of effort. The ventricles are beastly by comparison, comparison, they're the true pumps of the heart, and they need big, strong walls to shoot blood back out of the heart with every contraction. The whole thing is connected to the rest of your circulatory system by way of arteries and veins. We'll go into a whole lot more detail about these later, but the thing to remember first, if you don't already remember it, is that arteries carry blood away from the heart, and veins carry it back toward the heart. To differentiate the two, anatomy diagrams typically depict arteries in red while veins are drawn in blue, which incidentally is part of what has led to the common misconception that your blood is actually blue at some point, but it isn't. It is always red. It's just a brighter red when there's oxygen in it. So let's look at how all this comes together, starting with a big burst of blood flowing out of your heart. The right ventricle pumps blood through the pulmonary semilunar valve into the pulmonary trunk, which is just a big vessel that splits to form the left and right pulmonary arteries. From there, and this is the only time in your body where deoxygenated blood goes through an artery, the blood goes straight through the pulmonary artery into the lungs where it can pick up oxygen. It finds its way into very small, thin-walled capillaries, which allow materials to move in and out of the bloodstream. In the case of the lungs, oxygen moves in and carbon dioxide moves out. The blood then circles back to the heart by way of 4 pulmonary veins, where it keeps moving to the area of lowest pressure, because that is what fluids do, and in this case, that's the inside of the relaxed left atrium. Then the atrium contracts, which increases the pressure, so the blood passes down through the mitral valve into the left ventricle. So the thing that just happened here, where a wave of blood was pumped from the right ventricle to the lungs and then followed the lowest pressure back to the left atrium, there's a name for that. It is the pulmonary circulation loop. It's how your blood unloads its burden of carbon dioxide into the lungs and trades it in for a batch of fresh oxygen. It's short, it's simple, at least in the way I have time to describe it, and it's just delightfully effective. Of all the substances you need to continue existing, oxygen is the most urgent, the one without which you will die in minutes instead of hours or days or weeks. But it's pretty useless unless the oxygen can actually reach your cells, and that hasn't happened yet. For that, your newly oxygenated blood needs to travel through the rest of your organ systems and share the wealth. And that fantastic journey, known as the systemic loop, begins in the left ventricle when it flexes to increase pressure. Now, the blood would like to flow into the nice low-pressure left atrium where it just came from, but the mitral valve slams shut, forcing it through the aortic semilunar valve into your body's largest artery, nearly as big around as a garden hose, the aorta, which sends it to the rest of your body. And after all your various greedy muscles and neurons and organs and the heart itself have had their oxygen feast at the capillary bed buffet, that now oxygen-poor blood loops back to the heart, entering through the big superior and inferior vena cava veins straight into the right atrium. And when the right atrium contracts, the blood passes through the tricuspid valve into the relaxed right ventricle and right back to where we started. This whole double loop cycle plays out like a giant figure 8, heart to lung to heart to body to heart again, and runs off that constant high pressure, low pressure gradient exchange regulated by the heart valves. So the first lub that you hear in that lub-dub is made by the mitral and tricuspid valves closing. And they do that because your ventricles contract to build up pressure and pump blood out of the heart. This high pressure caused by ventricular contraction is called systole. Now, the dub sound. And just to be clear, I'm not talking about dubstep sounds. That's the aortic and pulmonary semilunar valves closing at the start of diastole. That's when the ventricles relax to receive the next volume of blood from the atria. When those valves close, the high pressure blood that's leaving the heart tries to rush back in, but runs into the valves. So you know when you get your blood pressure measured and the nurse gives you 2 numbers, like 120/80. The first number is your systolic blood pressure, essentially the peak pressure produced by the contracting ventricles that push blood out to all your tissues. The second reading is your diastolic blood pressure, which is the pressure in your arteries when the ventricles are relaxed. These 2 numbers give your nurse a sense of how your arteries and ventricles are doing when they're experiencing both high pressure, the systolic, and low pressure, the diastolic. So if your systolic blood pressure is too low, that could mean that, say, the volume of your blood is too low, like maybe you've lost a lot of blood or you're dehydrated. And if your diastolic is too high, that could mean that your blood pressure is high even when it's supposed to be lower. Considering how much we've talked about the importance of homeostasis, it should come as no surprise that blood pressure that's too high or too low, or anything that affects your blood's ability to move oxygen around, can be dangerous. Prolonged high blood pressure can damage arterial walls, mess with your circulation, and ultimately endanger your heart, your lungs, brain, kidneys, and nearly every part of you. So I guess you could say that the best way to break a heart is to mess with its pressure. But good luck trying to write a song about that. Today you learned how the heart's ventricles, atria, and valves create a pump that maintains both high and low pressure to circulate blood from the heart to the body through your arteries and bring it back to the heart through your veins. We also talked about what systolic and diastolic blood pressure are and how they're measured. Thanks to our headmaster of learning, Thomas Frank, and to all of our Patreon patrons who help make Crash Course
You want to go for a break and then we can start the rest of the things?
Yes, miss.
Yes,
Okay.
ma'am. Thank you.
Okay.
There's one simple vision hack anyone can use to improve vision.
Purkinje fibers, Purkinje network are fibers that receive conductive signals from the AV nodes, carries impulses
Is everyone back? I'm playing the next video.
Yes, we're back.
So you can say goodbye to your optometrist for good. Did you know that vision impairments have nothing to do with your eyes? The eyes are simply a camera for the part of the brain responsible for your sight. Here's the truth. No matter what type of glasses you wear or what eye treatments you try, you're only treating the symptoms, not the root cause. So listen up. Eventually, it will become harder and harder to see clearly, making you feel detached and less engaged in life. This is when your loved ones start to worry if you're able to manage
TV show or a movie. A patient is on the table in the emergency room bleeding from a stab wound or having OD'd on drugs when suddenly an alarm goes off and the beep, beep, beep of the heart monitor flatlines. It's cardiac arrest, and you can tell just by that sound that it's terrible. Doctors swarm around barking orders, and McDreamy or Dr. Gray or whoever the latest foxy doctor is on the TV show that you're addicted to grabs the paddles and pushes them down on the patient's chest and is all, clear! Then the patient's chest jumps up and everyone stares at the monitor waiting for those steady beeps to reappear. That is a pretty classic scene. When it comes to medical crises you see in popular culture, it's probably only rivaled by the poolside CPR scene or someone shaking an unconscious body, pounding on their chest and saying, "Don't you die on me!" Which, hopefully you know, is no way to keep someone alive. These are classic script tropes, but they contribute to some misconceptions about how defibrillators, CPR, and the electricity of the heart work. Because the truth is, CPR can help prolong heart function during cardiac arrest, but it usually can't save a life without help from a defibrillator. And when McDreamy, may he rest in peace, finally bursts out those paddles, that high voltage shock isn't turning the heart back on, it's actually stopping it. Confused? Well, I'm here to get your head to understand your heart. We'll get back to hot TV doctors in a couple of minutes, I promise. But in order to understand what's actually going on during cardiac arrest, we have to understand some basics about your heart cells. We've learned a lot about skeletal muscle tissue, how it's striated and contracts using the actin-myosin sliding filament dance you've heard so much about. The cardiac muscle is also striated and uses sliding filaments to contract, but the similarities end there. For one, their cells look pretty different. Skeletal muscle tissue has long multinucleate cells, while cardiac cells are squat, branched out, and interconnected, each one with one or two central nuclei. The cells are separated by a loose matrix of connective tissue called the endomysium, which is chock full of capillaries to serve up a constant supply of oxygen. Cardiac cells are also loaded with energy-generating mitochondria. In fact, mitochondria take up as much as 25 to 35% of each cell, making it resistant to fatigue, which is partly why your heart can beat nearly 3 billion times in a lifetime. Not surprisingly, the differences between skeletal and cardiac muscle tissues are key to understanding their functions. Skeletal muscle fibers are both structurally and functionally separate from each other, meaning that some cells can work while others don't. That's why you can grasp a delicate flower with the same hand that you can use to crush a soda can. Cardiac cells, on the other hand, are both physically and electrically connected all of the time. It takes precise coordination to create the high and low pressures required to pump your blood, after all, and cardiac cells need to be linked in order to have that perfect timing. And there's one more thing you need to know about your heart cells. Some of them can generate their own electricity. How in the name of Raymond de Vussens can that be? Well, rewind your brain to when we explored the electrical marvel that is the action potential and how it triggers both neurons and muscle cells. That process started by depolarizing the cell, that is, pushing the cell's membrane potential from negative toward positive past a threshold that triggered voltage-gated ion channels to open. Most cells in your body only depolarize after being triggered by an external stimulus or by a neighboring cell in a long chain reaction of action potentials that's set off by the nervous system. But that is not the case for a special group of cells found only in your heart, ones that can trigger their own depolarization. These are your pacemaker cells. Pacemaker cells are what keep your heart beating at the correct rhythm and ensure that each cardiac muscle cell contracts in coordination with the others, because you don't want your brain to have to send a series of action potentials every time you need your heart to beat. Your brain has got other stuff to do. So pacemaker cells are, in a way, your heart's very own brain, generating the initial spark that sends a current through your heart's internal wiring system, known as the intrinsic cardiac conduction system. This system transmits electricity along a precisely timed pathway that ends with atrial and ventricular contractions, also known as heartbeats. And it begins with pacemaker cells generating their own action potentials. In most cells, the action potential starts with the resting potential, which the cell maintains by pumping sodium ions out and potassium ions in, right? Then, when some stimulus causes the sodium channels to open up, the sodium ions flood back in, which raises the membrane potential until it reaches its threshold. Pacemaker cells operate the same way, except for that initial stimulus. they don't need it. Their membranes are dotted with leaky sodium and potassium channels that don't require any external triggers. Instead, as their channels let sodium ions trickle in, they cause the membrane potential to slowly and inevitably drift toward its threshold. Since the leaking happens at a steady rate, the cells fire off action potentials like clockwork, and the leakier the membrane gets, the faster it triggers action potentials. The pacemaker cells at the start of the conduction system have the leakiest membranes, and therefore the fastest inherent rhythms, so they control the rate of the entire heart. And those fast, leaky cells are found in the sinoatrial node, or the SA node, up in the right atria. They essentially turn the whole SA node into your natural pacemaker. After those pacemaker cells make themselves fire, they spread their electrical impulses to cardiac muscle cells throughout the atria. The impulses leap across synapse-like connections between the cells called gap junctions and continue down the conduction system until they reach the atrioventricular node, or AV node, located just above the tricuspid valve. Now, when the signal hits the AV node, it actually gets delayed for like a tenth of a second, so the atria can finish contracting before the ventricles contract. Without that delay, all the chambers would squeeze at once, and the blood would just splash around and not go anywhere. So instead, the atria contract and blood drops down into the ventricles, and then a moment later, the signal moves on and triggers the ventricles to squeeze, making the blood flow out of the heart. And there are two tricks to a good ventricular contraction. One, the ventricles are so large that the signal has to be distributed evenly to ensure a coordinated contraction. And two, the ventricles need to squeeze like they're squeezing a tube of toothpaste from the bottom up to accelerate the blood through the big arteries at the top of the heart. So from the AV node, the signal travels straight down to the inferior end of the heart and gets distributed to both sides. The path the electrical impulse takes to the bottom of the heart is called the atrioventricular bundle, also known by the more rad name the bundle of His, where it branches out to the left and right ventricles. Finally, the signal disperses out into Purkinje fibers, which trigger depolarization in all surrounding cells, causing the ventricles to contract from the bottom up like toothpaste tubes, at which point the whole cycle starts all over again. And everything I just described to you, from when the SA node fires to when the last of the ventricular cells contract, takes about 220 milliseconds. So that is how your heart beats. But I know what you want. You want to get back to talking about TV shows and McDreamy and his paddles. It's totally understandable. Okay, so picture all your individual heart cells as a bunch of musicians in an orchestra. They all sound really great together, but then the conductor suddenly needs to go to the bathroom. And it sounds okay at first, but then the tuba gets a little weird and the triangles have a beat off, and soon everyone is playing a different note at a different time, jamming to their own personal rhythm. In the heart, we call this out-of-sync behavior fibrillation, and it can be caused by all sorts of problems, especially ones that affect the pacemaker cells in the SA node. In an orchestra, this just sounds really terrible. In a heart, there's no coordinated contraction, no lub-dub, no blood moving through the body, which means you will soon be dead. But then the conductor comes back from the bathroom break, taps her wand, and everybody stops. It's silent for a second before the wand comes up, and then they all start playing again, this time in unison. If your heart in fibrillation is an out-of-sync orchestra, then a defibrillator is that conductor. It stops the chaotic noise by overriding all the individuals and hits a sort of reset button, so everyone can start again on the same page. The paddles send so much electricity through the heart that they trigger action potentials in all of the cells at once. Then the cells repolarize and start leaking again, and the most leaky cells in the pacemaker SA node reach their threshold and fire first, resetting the rhythm that keeps everyone in harmony so your heart functions properly. And that is how hot doctors and their paddles actually stop hearts to save lives. Now, the thing about CPR, or cardiopulmonary resuscitation, is that it can't correct fibrillation. What those chest compressions can do is force a fibrillating heart to keep circulating oxygenated blood until help arrives. But if a person is in cardiac arrest, just breathing into their mouth and compressing their chest won't deliver the electricity needed to give the pacemaking cells a chance to reset. I think I just figured out why they call those TV doctors heartthrobs. It's a terrible joke. Anyway, today you learned how your heart's pacemaker cells use leaky membranes to generate their own action potentials, and how the resulting electricity travels through the cardiac conduction pathway from SA node to Purkinje fibers, allowing your heart to contract. And if you weren't too busy daydreaming about TV doctors, you also learned how defibrillators work to reset the rhythm of your heart. Thank you to our headmaster of learning, Thomas Frank, and to all of our Patreon patrons who helped make Crash Course possible.
What is going on, guys? Dawn checking in. Welcome to MIT, where we bring nursing to you.
Oh, ECG, forget it. We have to read the ECG, then we can do that. This is ECG interpretation. You guys work on this first, okay? And you have to tell me. The heart is enclosed by a tough sac called Evelyn.
The sac is called the. Well, it's the. Sorry, mom. Are we talking about the heart walls?
No, sac.
Cardio sac? I don't know, ma'am. Sorry.
Amina?
Pericardium. Is the
I cannot hear you.
Yes, pericardium, ma'am.
Yes. Good.
Oh.
Okay.
Pericardium.
Okay. The visceral pericardium is the which layer of the heart?
Outer.
That's outer.
That's the one closest to the heart, inside.
Outer.
No, that's the. Is that no?
It's the outer.
That's the part of the pericardium that is inside.
It's the outer layer of the heart.
Visceral
Peri.
is inside.
Peri.
The parietal is outside.
Parietal is outside, right?
Ma'am.
Visceral
Outer.
is outside. Outer. Yeah. Okay, next. Peri is going to be inside. It just go in. Okay. The bulk of the heart wall consists of
Myocardium.
Myocardium.
Okay.
Wow. Very good. Very good.
The wall separating the ventricles to the heart is called the
sternum.
What?
The ventricular.
Sternum is in the bone structure. How is going to inside the heart?
Septum.
My goodness.
Septum. Sorry, septum.
Interventricular
Intraventricular septum.
Intraventricular septum.
Septum. In the
Okay, I just hear only couple of voices. Not any others are participating. Okay.
Yeah.
If I don't participation, it's going to be the difficult for give me to the professionalism and the attendance participation marks. I'm telling you guys. Next question. Who is going to answer? Except Evelyn, Amina. Who?
Me. Maris.
Me.
Maris.
Okay. Okay, Maris. Okay. Aortic and pulmonary valves are?
This is the semilunar valve.
Good. Okay. Okay. Next one, Sabana. Sabana.
Yes, ma'am, I'm here.
What is the answer?
1 minute. Ma'am. Sorry, ma'am, I'm using my phone because my laptop's not working. The is called a pacemaker of the heart.
Oh, you are in confusion. Okay. Who is
that?
Joanna.
Pacemaker.
Joanna.
Yes, ma'am.
What is the answer?
The blank is called a pacemaker of the heart. Is it SA node?
Yes.
Oh.
Yes. Okay.
Yes.
From AV node, the action potential spreads into specialized muscle fibers called Santiago. Santiago, are you there? Santiago.
Hi, Miss. Sorry, my microphone wasn't working, Miss. Yes, Miss.
Give the answer of this one.
Oh, I'm not too sure, Miss. I'm not going to be honest with you. I'm going to be honest with you.
Asenet.
Okay, so that's for, you said the muscle. Is that the myocardium? Is this muscle? Hold on, let me read it again. Sorry.
Okay, try.
Is that the myocardium?
Purkinje fibers.
Sorry.
It's
I'm
going to
mixing
the
up the heart
signal.
wall.
Okay.
Yeah,
Okay.
mix up the heart wall.
Okay.
So that one was.
Okay. What is Christian? Are you there? Christiana.
Yes, miss, I'm here.
Okay, the volume of the blood pumped by the ventricle in 1 minute is called?
Cardiac output.
Okay, good. And who is next? Let me see. Go to the team. Let's see. Joanna answered. Amina answered. Kara did answer. Ying Hong. Next question. Okay. What is this one? The volume of the blood pumped out of one ventricle of the heart in a single beat or contraction?
It's stroke volume.
Very good.
Thank you.
Louis, the name of an increased heart rate over 100 BPM? Yes. What cardia? Huh? Try. What you are trying to tell? Yes, I am hearing you. Tell me. I cannot hear properly. What is the full name? Tachycardia. Good. Yeah. Okay, so you guys who didn't answer at all or didn't participate or I didn't able get chance to practice this one, okay? You need this one. Okay, next one. Okay, what is that? Oh, these you guys has to do. Okay, so let us see who didn't answer. Asne tried, Joanna tried, Mary's tried. Sabana didn't able to answer. Sabana has to answer. Christina did one answer. Amina did. Younghoon did. Okay, Fazada, Kada, Bharna did some answer. Jenaida also did. Kiss Mandal. Okay, Huda. Okay. Let me see. What is the answer? Okay. Huda, the left ventricle pumps blood into the Huda, are you there? Huda? Huda? Huda, are you there?
I'm muted. Sorry, you're calling me?
Yes.
Okay, yeah.
How you cannot hear me when you are listening my lecture? How you cannot hear
Sorry,
me, dear?
I can hear you now.
So if you cannot hear my lecture, how you are going to learn? So tell me, the left ventricle pumps blood into the?
The left ventricle pumps blood into the.
Here is all the options. Which one I should drag in?
Aorta?
Yes.
Yeah.
Let us see whether it's right answer or not.
I'm not sure.
Okay. We'll check later. Okay. Next one, who? Fazado? This one. Is the medical term for a decreased heart rate under 60 BPM?
That's the bradycardia.
Okay, let us do this one here. Why is not fitting is here? That's not right. It should be bradycardia. Oh, okay. The cara, the pointed tip of the heart that is direct towards the left hip is called
The
cara.
apex.
Okay.
Hello?
Yes, got it.
Okay.
Asnet, the inner lining of the heart is called
It's the endocardium.
okay. Santiago, now you answer. Blood returning to the heart from the body enters the right atrium via
Via the hold on, wait, it's on the tip of my tongue. To the heart from the body. Enters the vena cava, the
You need the
inferior end.
yes. You have to tell me the full name.
Inferior and superior, yeah.
Okay. Atrium. Okay, blood. Okay, who wants to answer except let me see who is in the team. Kara give answer. Fasado give answer. Luis. Okay. Okay. So tell me, blood returns to the left atrium from the lungs via yes. Blood returns to the left atrium from the lungs by the pulmonary veins, right? Good. Yeah, exact. Very good. Okay. No, it's okay. I have to go for everyone. Okay, so Sabana, you have to try one more. You have to do something, Sabana. In
Yes,
cardiac
ma'am.
cycle, the period of contraction is called
In cardiac cycle. 1 minute, ma'am. Sorry, let me zoom in. In the cardiac cycle, the period of contraction is called, and period of relaxation is called distal.
systole.
Is it oh,
Okay, then
systole and
systole,
distal.
diastole.
Distal, yes. Systole and diastole, yes.
This one. The AV valve is most often called
Mitral valve.
yes. Okay, lack of adequate blood supply. You guys may not be able to answer that one because you didn't do that one. So anyone knows lack of adequate blood supply to the heart is called
Ischemia.
Ischemia.
Angina
Okay.
pectoris.
And severe chest pain caused
Severe
by
chest pain
oxygen
caused by
deficiency
oxygen.
is myocardial.
Angina pectoris.
Angina
Okay.
pectoris.
Okay, let us check.
And again, pectoris.
Yay! We did 100% good. Good. So you guys can practice this one. This type of questions may come, okay? So let me see
Okay,
what
ma'am.
is the next one. Okay, Asnet, what is number one? Asnet? Can you hear me, sweetheart?
Sorry. Number one, you said, oh my God, you caught me off guard. Let me see, 1 second. I think that's oh my gosh, sorry. That's the semi. That's the semi
lunar valve.
lunar valve.
But what
Yeah.
the name of this semilunar valve?
It is the I don't.
Starts with letter A.
It's the arthroventral something.
I cannot zoom less. Okay.
It's the AV valve. I'm
No.
sorry, Miss. You got me off guard with this.
No, it's not the AV valve.
It's the art.
No, it's not the atrioventricular valve. No.
Number
What
one?
the atrioventricular valve is going to be? Is the atrial ventricle is going to be
No.
atrioventricular valve? No.
Number one, Miss, you said number one, right?
Number one. You told semilunar valve. But what is the name of that semilunar valve?
Isn't it the aortic valve?
What? No.
It's spelled AORTIC.
No, this is not the aortic valve. No. Oh, yeah. This is aortic valve. You are right. This is the aortic valve. Number one is the aortic valve.
It's the aortic semilunar.
Yeah, aortic semilunar valve. Okay,
Yeah.
aortic. You are before you are telling atrio, so it is still my ear. It was hearing atrio. It's aortic semilunar valve. Yeah, because you are telling me atria, so it's in my brain. It was so it's aortic semilunar valve.
Yeah.
Okay.
I
Okay.
can't call these names.
Joanna, number 3.
Sorry, I have problem calling.
Sorry, give me 1 second. Number 3. That's another valve. That's a down one. Is that the bicuspid valve?
Yes. What is another name of the bicuspid valve?
Mitral.
Good. What it does? When it opens?
It
During
opens
ventricular.
when the blood flows. It doesn't.
Obviously, when it will open when the blood flows.
Yes.
But what
So
condition it opens? When the ventricular systole or diastole. Which time this bicuspid valve opens? During the ventricular diastole or systole?
Give me.
Let Joanna answer.
Okay, diastole is when it relaxes. So systole?
No.
Because it going that way. I mean,
if there is a systole, if the ventricular pressure, systole means ventricular is contracting. If you contract, this valve is going to come down or is going to close. It's one-way valve. If the ventricle generates the pressure, this valve is flap-like structure. Is going to close. It is not going to allow the blood flow inside. When then it will allow? Diastole. That means when there is no pressure. That time the flap is going to fall down because the blood is there and the blood is coming from the left atrium to the left ventricle. These concepts make it clear. Questions will come. When the bicuspid valve opens, give you the option diastole, what is called ventricular systole, ventricular diastole, or left ventricular diastole, right ventricular systole, diastole. Make everything clear. All the capsid valve opens, bicapsid, tricapsid. We are constantly discussing this. Bicapsid, tricapsid valves open during the ventricular diastole when there is less pressure. And these two valves, bicapsid or tricapsid, closes when there is ventricular contraction. It is the opposite for the semilunar valve. When there is ventricular contraction, the semilunar valves open because blood is going out. Relax. I am talking about the contraction. Somebody is telling relax. When there is ventricular contraction, heart pumps, ventricle pumps, the blood force has to force out from the ventricle to the semilunar valve to the either the lung or to the aorta. So that time these valves open, ventricular contraction, semilunar valve opens and tricapsal valve closed. Ventricular diastole, semilunar valves close and tricapsid valves opens. You have to keep it very conception clear in your head. This is, I'm just telling the total ventricle, total atria. They can give you the question. Tricapsid valves opens. Give you the option, ventricular diastole, right ventricular systole, right ventricular arterial systole. They are going to make you confused. You have to know the right answer. When is going to open? Tricapsid valve?
In diastole.
Who is diastole? Who is
It's
going to be the diastole? Atrial diastole, ventricular diastole? Which side of the
the atrioventricular, the bicuspid and the mitral.
Listen my question. When the tricuspid, when I'm asking on the tricuspid valve, focus on the tricuspid. When the tricuspid valves will open?
During the relaxation of ventricle, ma'am.
Which ventricle?
It's
right ventricle.
Right
Ventricle, because
ventricle.
tricapsid valve is in the right ventricle. So if you doesn't know the conception clear, if they just told the capsid valves or bicapsid tricapsid valves, when it opens due to ventricular diastole or systole, that will be the one answer, ventricular diastole. If they specifically ask you when the tricapsid valve opens, then they give you the option when the right ventricle diastole, left ventricle diastole, right ventricle systole, left ventricle systole. What is going to be your best answer?
Right ventricle.
So you understand how the questions will come? Okay.
Yes.
Next, who can answer? Christiana, can you answer number 2? Christiana.
Yes, I'm here, miss.
Answer number 2.
Number 2, is it the pulmonary artery or no? No, it's not. It's the right atrium. Right,
Number
miss?
2 is the right atrium. It looks like a right atrium. Is it looks like right atrium, Christiana?
No, the right would be the red side. Yes, I'm confused on this one. Give me 1 second. Number 2, where the blue part is showing, right?
Yes.
I think it's the pulmonary valve.
What is that? Christiana, try again.
Pulmonary valve.
Pulmonary valve. Yes, it's the pulmonary valve. It is what type of valve? Atrioventricular or semilunar?
You said sorry, what did you say before?
Is atrioventricular valve or semilunar valve?
I think it's the right. Oh no, so it's in the middle. I think it's a semilunar. valve?
It doesn't matter whether it's the middle or left or right. It doesn't named as per your right or left position. It is due to the shape and due to the position. So it's not the middle is means semilunar. Semilunar is the shape. It's not the flap like. It's a semilunar type. So see the flaps are like the half moon type. Say semilunar. Yes. It's called the semilunar. That's why it's called the semilunar. And this is present in between what? This bulb is present in between what?
Miss, I don't understand. It's present in between, like you're saying, the valve, it's present in between.
Mm-hmm. What is this one? This structure? This side, what is this? What is the name of this chamber?
The left chamber.
This is left. Evelyn.
Maybe it's a bad diagram, miss. I don't really see the diagram.
Yes, ma'am. It's between connecting the right atrium and the right ventricle.
What is this one, Kathleen? This one?
That's the tricuspid valve, ma'am, the number 4.
No, I am telling about the number 2. Yes, this valve is located between which chambers?
Between
the right.
Right ventricle and the right atrium.
No.
Right
Between
ventricle
right
and
ventricle and left atrium.
The pulmonary arteries, ma'am.
Oh, okay.
I
that's what you're
totally
trying to
failed
say.
today.
Oh, okay.
Today
Miss,
my
sorry, I
total
didn't
lecture
understand the
is failed.
question. I'm
Yeah,
so
Totally,
sorry.
I really feeling failed today. Whole
No,
session.
miss, I didn't understand the question.
Yeah, it's going to the pulmonary artery, going to the lungs. This pulmonary valve is going, it's a pulmonary artery to the lungs, and it's situated between the right ventricle below and the right atrium above.
Tiziana, how you think this is the left? Can you tell
Sorry,
me?
miss, it's not the left, it's the right. It's the right.
Yeah.
The blue is the right, I remember.
Yeah.
How the blue represent the deoxygenated blood. You see the vena cava here. How you are thinking this is the left chamber? I just failed today.
No, miss.
Yes, I am.
It's a bad diagram, though.
No, it's not at all bad diagram. It's very good diagram. It's a very clear diagram. Very clear that nobody is going to tell anybody. It's very clear. 3 flaps tricapsid, 2 flaps bicapsid. This is the valve here. This is the connection opening. This is the semilunar valve. This is the semilunar valve. Nobody is going to give you better diagram. This one. No, that I don't agree.
Okay, miss.
Your heart, that throbbing, beating muscle, is probably the most iconic organ in your.
Miss Moon Moon,
Yes.
is it the pulmonary trunk and the right ventricle?
What you are telling?
Is
Which
that
one?
the two spaces? You remember how you were saying the pulmonary valve?
Yeah, that's the pulmonary valve. It is connected. Pulmonary valve is present. What Evelyn told is between the right ventricle and your pulmonary artery.
Artery. Yes.
Yes.
Yes, ma'am.
This I'm discussing so many times, one by one. So you can understand how much study you have to do for this one. This is the basic. Then you have the electrical total PUA total chapter of the ECG. Now let us start. We have some time. ECG. We'll see how much we can go for today. So we are going to learn mainly the 12-lead ECG. ECG stands for electrocardiogram. So it's going to tell you how to correctly identify patient. You guys should know that, how to prepare a patient, explain the preparation and maintenance, how to maintain the ECG equipment, what are the functions of the electrodes, how it be placed in the 12-lead ECG. You see in the picture or in the tracing, which leads are measuring what waves are in electrography are present, what type of graphs is showing, and how to adjust the electrocardiogram paper to accommodate for pulse rate, how we are going to get the pulse rate from the ECG, and what are the lead replacement errors can make, some artifacts can cause, and how to take care of that, and how to label a complete ECG, and ultimately what is Holter monitor. So electrogram or electrocardiogram, either ECG or EKG, not EEG. What is EEG stand for? There is always, there's people make mistake between EKG, ECG versus EEG. What is EEG?
Is that for your head?
Electrocephalogram.
Electrocephalogram. Cephalo means head and gram. When is the stressing the brain activity is called the EEG. Electrocephalogram, EEG. They call the EEG. And EKG or ECG is the electrocardiogram. When you feel any abnormal heart rhythm, palpitation, shortness of breath, dizziness, chest pain, chest pressure, any type of things, doctors generally ask for an electrogram. So what is the abnormal heart rhythm, which is called the arrhythmia? Any abnormal heart rhythm. So it's the low or high, anything is beyond normal is called the arrhythmia. So any abnormal heart rhythm, palpitation, when you are feeling the veins is bounding, palpitation or getting slow, if there is a, which it may cause due to the blocked or narrow arteries in the heart, which causes the coronary artery disease and causing chest pain or a heart attack. If the coronary artery or coronary artery branches got narrowed or blocked due to some reason, you may see pressure, difficulty in breathing, you may feel chest pain, or which may lead to the heart attack. How well certain heart diseases treatment such as pacemaker are working. So also from there, you can see how your SA node, AV node, these are working from the ECG graph, seeing the ECG graph. So from there, you can see the whether your SA node is working, AV node is working or not. Whether the SA node is working properly means your atrium is working good. If your AV node is working properly or AV nodal system, then your ventricles are working good. If SA node has some problem, then it can generate problem in the whole heart, because SA node is a natural pacemaker which sets the main signals for total entire heart contraction. ECG, you may need an ECG if you have any of the following signs and symptoms: chest pain, dizziness or lightheadedness or confusion, heart palpitation, rapid pulse, shortness of breath, weakness, fatigue, decline in ability to exercise. So, what is the electrical basis of the ECG? The electrical activity of the heart is getting in the printed in the graphical form, that is the ECG, electrocardiogram. So you see the ECG, gram means picture, cardio, you have learned this one for the medical terminology. Electro is from the electrolytes, that's the polarization, depolarization, what the video shows. So the electricity generated due to the ion movements, which as the ions are positive ions, negative ions, which generates the electricity. And that electricity on the heart, when you are seeing in a picture or gram, is called the electrocardiogram. So cardiac monitor depicts electrical impulses or monitor screen or oscilloscope. So electrocardiogram, questions come, electrocardiogram, electrocardiogram. You may feel electrocardiogram is the ECG is not right. Electrocardiograph is the machine which used to do the ECG to generate the electrocardiogram. So electrocardiogram is the picture or tracing of the heart electrical activity, and electrocardiograph is the machine or the apparatus which we use, the ECG machine is the electrocardiograph, which is used to generate the electrocardiogram or performing or doing the ECG. So what is ECG? Each line is important and this can become as a question. ECG is the graphic tracing. What is ECG means? They are going to give you couple of options, very close options. It is the tracing of electrical activity of the heart. It is not the mechanical activity. The questions come electrical, mechanical activity, chemical activity, but it's the electrical activity. That is the electrocardiogram. Electrical impulses given up by the heart are picked up by the electrodes. What the electrodes? We are going to put some stickers. What is the nature or importance we are going to discuss, but electrodes we are going to put. What the electrodes do? Why you put the electrodes? Because the electricity which generates in the heart is very low voltage. So electrodes pick up those signals. Electrodes pick up those signals and send through the machine to generate the graph. So electrical impulses given up by the heart are picked up by the electrodes and conducted into the machine through lead wires. So we connect the electrodes, we have some wires. Electrodes pick up the heart signals and then through the lead wires they send it to the machine, and the machine has a couple of components which helps to transmit or transfer that information in the form of a graph. What are the electrodes? As I told you, they are composed of substances which is a good conductor of electricity, so that they can, whatever the weak electrical signals they are getting from the heart, they can pick it up, amplify, and smoothly good conductor means it can transmit smoothly, effectively, and strongly to the specific through the lead wires to the machine. So electrical impulses given up by the heart are very small. What is the voltage? 0.002 volt, which is generated by the heart. If heart generates too much electricity, your whole body is going to be electric. So the electricity which is generated is 0.002 volt, and that is sufficient to do that huge pumping action of the heart. So around 0.002 volt. So to produce a readable ECG, they must be made large amplified. So electrodes help to amplify and helps to convey the signal. So by the device known as the amplifier located within the electrograph. So electrodes, good conductor of the electrolytes or electricity, they picked up the low signal, send it to the wires through a machine where they have the amplifier inside the machine. Then the amplifier amplifies the signal, and then through another structure is the galvanometer, which generally transfer the signal to form in the print in the paper as a graph. So what is here? So you are putting, these are called the electrodes. we are going to learn which electrodes is going to put where, which electrode reads what activity of heart. But these are the electrodes, they are connected through the wires. They all are connected, all wires then connected through a basic one. So these are the electrodes, these are the wires. The electrodes are the good conductor of electricity. They picked up the signals from the heart and they transport to all the wires to the machine where you have the galvanometer. So all the branches ultimately come to a point in the port, and then from there it goes to, this is the electrograph or ECG machine. Inside the ECG machine, what is there? It is as the amplifier. So amplifier amplifies the voltage, and this voltage, these then transfer in the electrograph by a through the galvanometer. So amplified voltage is changed into mechanical motion. So from here we have the electrical activity. This electrical activity is picked up through the electrodes from the heart, go through the lead wires, and then lead wires is going through the connected to the amplifier. Amplifier is amplifying the signal, and this amplifier signals is transferring it connected to the galvanometer, which is making it to the mechanical motion so that it can be printed on the graph paper. So basically this comes like this, and then it ultimately from the galvanometer to the stylus or head or pen, it generally printed on the electrocardiograph paper. So how this is going to be read? There are mainly three components, basic major three components of the electrocardiogram, and we are going to learn different structures which is depict what. Okay, so generally we use the 12th lead ECG machine. This is the 12 lead ECG machine. There are the programs that you, whenever you do the this is the hospital base, but whatever in our lab has, that's a different one. But in the hospital, sorry, this already program, we are mainly, we do the 12 lead ECG, but sometimes you have to do the 15 lead ECG. Will tell you when there is a problem, position of the heart, or there is something damage in the backside of the heart. So then you have to do the 15 lead ECG so that we can see the backside of the heart. But in general, the ECG is 12 lead. That means it reads in the 12 points. That is called the 12 lead ECG. Okay, so this is sometimes is connected with the blood pressure, sometimes it's not. Pre-hospital 12 lead unit. So we don't have this one. So each organization has their own machine, and that they are going to train you how to use the machine. But you have to know the basic concepts, how it works, what is the meaning, interpretation. So electrical basis of the ECG, electrical impulses present on the skin. So the heart is generating the electricity. That electricity ultimately is a voltage, electric. So it is coming on the skin surface, but it's very low voltage. So this is what is, again, we are picked up through the electrodes, and electrodes is sending to the ECG machine where you have the amplifier which is getting amplified. And ultimately that electricity is transforming to a mechanical motion through the galvanometer, and which is connected with the printer head, which is called the pen, which is called the stylus. And the stylus is recording or printing the heart activity, heart electrical activity on the paper in a form of a strip, is called the rhythm strip of an ECG strip. So when is going printing continuously, what is the total is called the rhythm strip. The record is printed on a graph paper at a set speed. This is important. Where the stylus pen move, how fast? 25 millimeter. So speed, the printed on the graph paper is 25 millimeter per second. To demonstrate the electrical conductivity of the heart. This is question. What is rhythm strip? Electrical activity of the heart, which is printed on the ECG paper, is called the rhythm strip or ECG strip. Who transform or amplify the signal picked up by the electrodes? Amplifier. Who transfer or convert the electrical signals to the motion to be printed or recorded in the graph paper? Is the galvanometer. Speed of the electrical stylus or the graph paper, how fast is going to move, is going to 25 millimeter per second to demonstrate the electrical conductivity of the heart. It has been settled. It has been set. Recording is a plot of voltage of the electrical versus vertical axis against the time. So when is recording, we are going to show the recording is in the vertical axis, which is going in the long or the height side, is give you the voltage, and this side in the base side or the x-axis, it is giving the, it's called the x-axis or horizontal axis. It gives you the time, how long it is taking. So voltage versus time. So electrodes are connected to a galvanometer that records a potential difference. Okay. How the graph papers looks like? You can see there is a graph paper. There is some big red marks. It's not comes blue. It comes in the red. So there is a red big mass, and each one has 5 square in between. So one big red mark. 1, 2, 3, 4, 5 on the horizontal side, and vertical side is 1, 2, 3, 4, 5. So one big red mark, separated marks, is composed of 25 small squares. Why you say the why? Because each square is important, because the pen is moving here. So you can calculate from here the difference through seeing the difference in time of different waves, which represent the different part or functions of the different parts of the heart, whether is delayed or is faster. So from there, the doctors can understand, who reads the ECG properly, they can understand is there any defect or not. So basically, if you see, this is a 5 marks. Okay, so there are 1, 2, 1, 2, 3, 4, 5. So 5. Each one is the pen or the graph paper, which runs as 25 millimeter per second. It only, for this small square, it takes 0.04 second. Okay, so this is the only the small squares, it takes 0.0 meter. And what is the white? Is 1 millimeter white. 1 millimeter. So 1 millimeter takes time 0.04 second. So if you have this length, how long is going to take? 1 takes time 0.04 second. So to travel the 5 of them, how much second you will take?
0.2 seconds.
0.2 seconds. This is the 0.2 second. So travel from this side to this side. That means one full block marked area, highlighted marked area, is travels 0.2 seconds. Each one has different time interval, like the when you are going to see P wave, Q wave, R. So each takes in different place in different time intervals. So first you have to know the graph paper. So this is the red one, 1, 2, 3, 4, 5. So how is going to, if the speak like this. So from here you can understand, oh, that means it travels only 1. So that means it takes only 0.04 second. If somebody has arrhythmia, this is moving too fast, maybe it is going to take too fast, it's going to take 0.0 second. Who has the bradycardia? It may take long time. So from there, ECG, you can see is moving long, taking long time to grab the graph. So from there, this timing, this millivolt, which is the height versus the distance, time is very important. Is that graph paper, these squares are clear? One small, very small square, what is 1 millimeter wide, is takes 0.404 second. and total 5 boxes takes 0.4 times 5. So 1, 2, 3, 4, 5. It takes 0.2 seconds. Now ECG graph paper, we have learned also darker lines divide the paper every fifth square. This is the darker line. You can see this is the darker line. This is the darker line. Okay. So this is the darker lines divide paper every fifth square, vertically and horizontally. Again, last square measure 5 millimeters because one is 1 millimeter wide. So if it's 1, 2, 3, 4, 5, so 5 squares means 5 millimeters. If something, some peak or some graph traced like this, so I can tell it has been 5 millimeters. Maybe this wave needs 5 millimeters. If it is more or less, that means there is a heart problem. So last square measures 5 millimeters in height and weight. So 1, 2, 3, 4, 5. So height is 5 millimeter and weight is 5 millimeters too. Represents time interval of 0.2. 1, 2, 3, 4, 5. So 1.5 millimeter in length and wide, and the travel seconds it takes 0.2 seconds. 5 small squares in each last square. That I already told you. The 5 small squares in each last square. Now paper levels the machine at the constant piece of again 25 millimeters per second. Okay. So its paper is set so that paper, when the pen is going to move, paper is going to move and pen is going to print that. So paper is moving and stylus or the pen is going to print. So that's why is speed is 25 millimeters per second or per second. Amplitude or voltage, it has been shown in the longitudinal axis or called the y-axis or the vertical axis. So amplitude or voltage are measured on the vertical line on the graph paper, y-axis, vertical axis, or and what I call y-axis, vertical axis, and the longitudinal axis, anything. And time is measured on the horizontal line or baseline. Okay, so this is x-axis. Okay, so increase, if you increase the speed to 50 millimeter per second, what is going to happen? It's going to hide the subtle ECG findings, the subtle findings. If there is maybe 1 or 2 waves are going to overlap each other, then you cannot distinguish or you cannot find exactly what is happening there. So waveforms becomes wider. So doubling the standard rate, that is the 25 millimeter per second, reveal the subtle ECG findings hidden at the slower rate. At the slower rate means 50 millimeters per second divided by 20. In general, nobody does that until and unless too much bradycardia, too much slow, is taking long times, you know, heart is probably running 30, 40. So that time they sometimes double the speed so that they can understand, otherwise it's going to take time. In general, set is 25 millimeter per second. These are the good for people with tachycardia and particular arterial flutters wave. Speed needs to be indicated on the tracing paper. So if you change the speed, you have to make the sure it has been seen or recorded in the ECG paper. ECG leads, what are called the ECG leads? We have the electrodes and leads. Electrodes, I already told you, is an adhesive pad that contains conductive gel, which is a good conductor for the electrical impulses or electricity and attached to the patient's skin. Enables the recording of the electrical impulses which generates from the heart. What are the leads? Leads is how these electrodes are connected to the cardiac monitor. That means that through the machine and the interconnected with each other through the wires. So we have 3 leads. One is positive lead, one is negative lead, and is ground lead. There are 3 types of leads that you have to remember. 3 types of leads: positive leads, negative leads and ground leads. So here we have couple of different types of leads. Bipolar leads. There are some leads which can show in the graph paper positive and negative. So that is called the bipolar. They can read positivity and negativity. That's called the bipolar leads. What are the limb leads? You have to remember this one. We have two different types of leads for placing limb leads and chest leads, or the another name of the chest leads is the precordial leads that we are going to learn again. So limb leads are the leads which place in the limbs. What are our limbs? Two arms, two hands, feet or legs, right? So limb leads, we put 4 electrodes, but we have 3 limb leads because one is ground lead. So that grounding, so it doesn't matter that much, only for the grounding. So we have limb leads 1, 2, and 3. So lead 2 is the most common due to the ability to visualize P wave. You are going to say P wave is the arterial function. When the atrium contracts, the P wave generates, which has been seen through the activity of the lead 2. How they are going to read when you are going to put the leads in the 2 arms and left leg. We are going to put another one right leg, that is the ground. It doesn't measure any activity. That's why it says 3 limb leads, 1, 2, and 3. So we are going to put leads right, left, and left leg. So when lead 1, it goes from right arm, it measures the activity, heart activity from right arm to the left arm. Lead 2 goes from right arm to the left leg, and third lead from left hand to the left leg. So 1 is from arm to arm, lead 2 from right to left leg, and lead 3 from left arm to left leg, because we are not considering the right leg. Right leg is the ground leg. That is the, which is called the neutral, kind of that grounding, so that no noise come. So these you have to remember which lead is from going from which to which. Lead 1 from right arm to left arm, lead 2 from right arm to left feet, left leg, and lead 3 from left arm to left leg. So how is it that this is the right arm, left arm, and then we instead of leg we can put in the lower portion of there. So it said the left leg. So you can put the left leg. How is measured? It's measured from the right arm to left arm, lead 1, lead 2 from right arm to left leg, and lead 3 from left arm to left leg. This is called the Ethiopian triangle. Ethiopian's law or Ethiopian triangle. This is the triangle. This is going to ask you what is the Ethiopian triangle. This is when it reads the 3 limb leads, read the heart activity. Lead 1 from right arm to left arm, lead 2 from right arm to left leg, and lead 3 from left arm to left leg. So you can see why these are called the bipolar leads. It has the positive end and negative end. Lead 1. Lead 2 also has the same thing. These are the 2 bipolar leads. So imaginary inverted triangle formed around heart by proper placement of bipolar leads. These are all bipolar leads. Okay, plus minus, plus minus, plus minus. So bipolar leads. Top formed by lead 1, right side formed by the lead 2, left side from the lead 3. So top 1, lead 1, lead 2, lead 3. Each lead represents a different look or view of the heart. Each lead, they looks different planes or different areas of the hearts, view of the hearts. This is called the Inthoven stated this law, who discovered this law. So that means lead 1 plus lead 3 is equal to lead 2. So lead 1 plus lead 2 is equal to lead 3. That is their law. This is you have to remember, we have nothing to do this one. I cannot explain why he did that. But he stated that lead 1 plus lead 3. That means from right arm to left arm and left arm to left leg, which is equivalent to lead 2, which is called the Indovens law. Okay. So now see, there are different planes of the heart. Let me see how much is the okay. This we are going to lead placement we are going to do tomorrow. So just we're going to stop here today. So frontal, what is the slide number? Slide number. Yep.
22.
22. We have to do a lot tomorrow. Okay. So we have different planes. One is frontal plane, which is front side, and it's the horizontal plane. How it looks the heart activity. So frontal plane, what the limbs leads took at. And horizontal plane, where the V leads look at. V leads is going to be the chest leads. So these are the limb leads and chest leads. There are two different type leads, and these are looking at the different angles or planes of the heart. So this I already told you, just tell you. So leads 1, 2, and 3. So specific planes, 2 arms should be placed between the shoulder and wrist. Basically, nowadays we are putting it here. Any electrode should not be placed on any bone. It should be on the muscle. Okay. Generally, all electrodes, the wires that called the clip, they are colored, but you can, whenever you are connecting this one, you have to look that which one you are connecting is with the going properly with the port where all the leads wires are connected. So when you are going to see the ECG next week, it's going to be more clear. So right arm and left arm, we put 2 electrodes, which is called the lead 1 and lead 2. And then we are going to put one in the left leg, which is the lead, but this is called the lead 1, this is called the lead 2, and this is called the lead 3. But these are the electrodes. For you place 3 electrodes, and they are measuring again. Once again, I repeating, lead 1 record the activity from the right arm to the left arm. Heart's activity, how is going from here. So that means there is atrium. Then this activity, left arm to left leg. So they are going to cross because the activity through the heart, which is crossing the atrium and ventricle. So do from right arm to left leg. So 2 leg leads should be placed between the hips and the ankles. You can put it here. Nowadays, we can put it here also. The right leg is called the, again, it's green colored. This is called the ground. Again, it's ground. It has no function in the heart activity recording. So these limb leads are also called the augmented leads. You have to have a lot of, it's a very confusing thing, which is augmented leads, which is the limb leads, which is what is the electrodes placement versus this one. Then we are going to cover the chest leads. So these limb leads are called the augmented limb leads. So why is called augmented leads? These leads use the 4 limb leads to do the measurement or the heart activity measurement. So what is called leads is A, or for the augmented, we have the AVR. AVR means augmented leads, right ventricle. AVL left. AVF is front. So utilize the 4 limb leads. Heart is the focal point. Obviously, current flows from heart outward to the extremities. So when electricity generates, heart contracts. Then when the repolarization happen, electricity go outward to the extremity. So ECG machine must boot amplification due to the position of these leads. They picked up the signals and amplify it. So if you see what we are taking, minus plus is going the lead 1, lead 2 is going from minus to plus. It has both things, again plus and minus, so bipolar leads, lead 2. So lead 1 leads the activity, lead 2 from the right arm to left leg, and lead 3 is called from the left arm to left leg. So these are the bipolar leads, and these are called the augmented leads, and it calls the Itoven's triangle. So it picks up the activity. So next, so this what is called as it is reading the activity here. So it's called the AVF. It is reading the activity from up to down. So it's called the AVF. This one, AVL, is reading the activity from here to here. That is called the AVL. These are very complicated. Just remember, they have the AVF, AVL, AVR. These are called the augmented leads. And AVR is measuring from left side to the just opposite to the right arm. That's the approve this. I'm stopping this one. Tomorrow we are going to work from the chest list and go on. Okay. I request you guys tonight, please read all the Microsoft PowerPoints. Whatever I told you, go through that. Otherwise, ECG, answering ECG is going to be very difficult.
Yeah, that's true, ma'am. It's very complicated.
Very complicated.
Yeah.
I was telling you guys, you are not paying attention to the hematology on those are things, those are much easier. ECG is very important. The 2 chapters you are going to face really difficulties, what I seen from my experience, the ECG and the quality assurance and math.
Okay.
After this is the quality assurance and math. In between, there is a midterm. So you can see after ECG, there is no time for you to get too much ECG, read ECG time. By this time, I told you to review all the midterms. Only as per their timing, only you have 8 hours,
Yes.
2 days to do the midterm. Starting
right,
from
ma'am.
anatomy, physiology to ECG.
Yeah.
So
And are we
try to
going
read.
to
Who
have-
will read? You can see whatever you know. I can complete this one today, but I am not getting answer about the basic things what I teach you before.
Yeah, it's confusing, ma'am. Me too. I'm quite confused.
Even at the beginning, whatever I have to teach you, that the heart structure, heart septa, this, that, SA node, FE node, I told you couple of times.
Yeah.
Couple of times I teach you, those you cannot answer. So then I have to rephrase those things first you, then I can go to the ECG replacement, because everything is going to be connected now. Now you are getting the electrodes, electrolytes. Now how these electrodes are reading which part of the heart function and how is going to be represented there. And what are the different part of the ECG recording? It's not easy to remember what is the Q segment, what is the P segment, what is the wave complex. It's complicated. It's complicated.
True.
At the beginning, when you are going to be used to it, it's going to be easy.
Yeah.
Okay, so please, I'm stopping it here. It's already 1. So yeah. So
Yes,
today, so Rugiato not present, Alexia is not present, and who else is not present? I already did this one. Please read. I am telling you guys, I am today I didn't get any. I don't get frustrated, but today I am feeling at one point what I teach you guys in the anatomy and the hematology just waste.
Miss, it's not wasted. It's just
No, if you cannot remember Asnet, you can understand we cannot progress. You understand? Waste means I am not waste of time. I am not telling you the waste of energy, waste of time, because if you cannot remember, you have to refresh it, right? So you cannot go forward. That's what I'm trying to mean. It's hard. It's hard. I'm not telling you it's hard. That's what I'm telling you. It's not easy.
Yeah, that's true, ma'am.
It's very hard.
It's hard.
Yeah.
It's a
To be
short
honest
one, but
with
it's
you,
hard.
you guys doesn't need so much to know, but what else we can do? It's in the course. We have to teach you.
Yeah.
Yes,
In your
miss.
practical profession, you doesn't need anything. If I'm the program director, I'm going to cut the course in 6 months.
Wow.
Yeah, and I'm going to focus more on the practical and whatever needs. Maybe I can go 2 days, 3 days from the same thing to give it everything is their head. But what we can do, I feel helpless also.
Are we going to have our exam on ECG on Friday, ma'am?
Yes, yes, I have no choice. Yes.
Yeah, okay, thank you.
Probably on Wednesday, I'm going to post you the review. You guys can work on that. Because tomorrow, I see if tomorrow we can cover more important things, then maybe I can send you the reviews tomorrow. And
Yes,
reviews the tomorrow. You guys can work on that. And then next week we are going to be the lab, and following week we have to do 2 more units and 1 or 2 more units, and then then you have to do the ECG final.
Yeah, we have to do the finals, and then the
ECG
18th and the
final,
19th
then
is
probably
the
1 day
midterm.
off, 1 day, probably by Wednesday you have to do the ECG final. And then you have to do the midterm. So maybe I will just extend it to the Friday, the ECG final. And then after the weekend, the next Monday, you can do the midterm. If everybody exists to get time to read. So you will be in the midterm, and the final, it has to be on campus.
Yes, ma'am. Okay, ma'am, yeah.
We'll talk next week, so how you plan it, okay?
Okay, ma'am. Thank you.
But right now, today, please, please, please read
Read.
it, okay?
Yeah. Thank you, miss.
Okay, sorry, because, I feel stressed because I know it's hard.
Yeah, just by your lecture, ma'am, it's quite hard. It's really quite difficult to understand.
But I tried. I know I don't try to make you, complicated, but it's more complicated. That's why I'm telling the same thing repeatedly, going back and forth, asking you the question so that it can go and stay in your brain. It's not easy.
Yes.
At the beginning, when I was a student, it was hard for me. I have to go through so many times. So I can understand on your perspective. That's why I'm just telling. Right now, every year I'm teaching, so it's like a movie to me. But not for it's movie to me because I can see, visualize everything what is going, because I'm teaching every year, every time, maybe 2 times in a year. So that's why it's not easy. But it's going to, when you guys going to do the ECG, maybe you are not going to remember all these complicated things, but you are going to know what is what, basic things.
Yeah, that's right.
Yeah. Okay. Okay. Thank you. Please.
Thank you.
Okay.
See you tomorrow.
See you. See you.
See you
Thank
tomorrow.
you.
Bye.
See you tomorrow.
Okay. Please study.
Yes, I will.
Okay.